Hello, welcome to another lesson on Pre-Calculus for Business with Professor Checo. So today's focus is going to be Chapter 4, Section 5, the inverses of a square matrix. So let's go ahead and take a preview at this assignment. So we have 24 questions. Let's get into it. All right, see if I can open up the textbook. Will it open me up to the correct chapter? Let's see. 4.5. Yeah, cool. Let's maximize this and take a look. So, an identity matrix for multiplication. So, guys, if you want to think about matrices, just think of it as multiplication. What is the identity for multiplication? Well, it's going to be 1, which means that all your variables here would be 1. So, this is an example of an identity matrix. Because when you multiply the identity matrix times any equation, it always gives you, when you multiply the identity matrix times any matrix, it always gives you the same matrix, and so forth. Now, just if I were to say there's an operation for multiplication, there is an inverse to that, which is division. Now, it's a little different in the way that inverses work with matrices like division. So for example, if I take 6 and divide it by 2, it's 3 no matter whether it's however how I think about it. But 2 divided by 3 does give me 6 divided by 2 gives me 3, but 2 divided by 3 gives me 1/3. So there is that it's not going to exactly, if you don't divide it correctly or multiply it correctly, it's going to be different. So here, when you multiply something from the outside, so here, if you think about this, im is equal to m times I, which is equal to m. That's just identity matrix, nothing there. All right. Moving on, inverse of a square matrix is a multiplicative inverse, additive inverse, just like we said. We can multiply and divide. So here, if it is n times m, and it's a p times q, m has to be equal to p, and then our matrix will be the outsides. So whenever we multiply, the insides have to be equal, right? So whenever I think of an inverse times the matrix is equal to the matrix times the inverse, and that's always equal to 1. So the insides have to kind of match. Let's see if they give an example of it. No, it's just I'm finding the matrices and all that. More examples, more examples, more examples. Just trying to get that identity. So how do you get, I think this question is how to identify the matrix. You just make it so that it's 1, 1, 1. All right, inverse of a square matrix. If m times augmented I is transformed by row operations IB, then the resulting matrix B is m to the inverse. However, if we obtain all zeros in one or more rows in the vertical, then the inverse does not exist. So obviously, if it's going to give you a false statement, then you can't have the inverse. The inverse does not exist of a function. Just like you can't, All right. So here there is a formula where a is equal, if you have a number and this is your matrix, the inverse is equal to all of this, which is just 1 over d, where d is the cross sectionals subtracted from each other, times all those values. So there is like a little trick that you can do, but we have a calculator for that. Cryptography, code, getting a message, translating a message, and getting it back to the original message. Yeah, they use matrices for this because that allows you to do a lot of operations in bulk. All right, so enough. All right, so let's see. Find both the opposite, additive, inverse, reciprocal, multiple of 13. Isn't that just negative 13? Yep. Cool. Reciprocal will be 1 over 13. And then, what's the opposite? I'm not going to do that. This is the same exact question. You guys got that? Does the given matrix have a multiplicative inverse? No, because it's not a square matrix. Only square matrix have inverses. Does the given matrix have a multiplicative inverse? This is 0, 0. I'm going to say we're going to divide by 0 of only zeros. I think this one. Yeah, multiplying the matrix by another 2 by 2 will give a matrix consisting only of zeros. Therefore, there's no, like, 0 doesn't have an inverse, right? Find the following matrix products. So this is just this times that. Guys, Desmos, when you go to the main homepage on desmos.com, there is a matrix operator, and use that. We've done this, but this is also just a matrix. So this is just this is just the identity matrix. Oh my goodness, I'm so foolish. So then this is just -1, -9, -5, and 5. Cool. Same exact thing for this one down here. I'm not going to do that. Moving on to the next question. Okay. Yes, I've completed. We'll write the following matrix. Note the product can be found mentally without the use of calculator. Yep, this is just the identity matrix. Moving on. Examine the product of the two matrices to determine if they are inverses of each other. If they are inverses of each other, then they would result in the identity matrix. So let's just view an example real quick. So what they're going to do is going to get that, and then it gives you the identity matrix. Therefore, yes, it is. Examine the two products to determine if each is the inverse of one another. Are the matrices inverses of one another? So there is a way that we can kind of figure this out without doing crazy amount of math. If I just find the inverse of one, the answer should be the other. So for example, if I do find the matrix, and this is -2, -5, 5, 4, enter, and then I find a inverse, that gives me that. No, because multiplying the two sides does not. No, because multiplying them does not yield that. It gives me that crazy decimal, whatever that is. Next. Examine the product of two matrices to determine if each is the inverse of another. So literally, I could do the same exact thing. I could find the inverse of one, and it better be the other. So let's just go back to Desmos, and if I just go here and just do a -3, 4, -7, 9, and I get, yep, these are inverses of each other. That's it. All right, same exact thing. You would multiply these two, find the inverse of one, see if they're inverses of each other. Without performing operations, explain why the matrix does not have an inverse, because it's not a square matrix. They have to be square matrices in order to be this. Explain it does not have an inverse. I'm guessing when we do this times that, 6 times 8 is 48. 48 minus 48 equals 0, so that's going to be 1 divided by 0. So D, remember how I said they gave me that equation? So D is equal to AD times BC, which is the crosses and then subtracted. So that's why. Equals 0, 1 divided by 0, undefined. Given M, find the inverse. So calculator, right? And then if I just put in -1081, and that gives me a 2 by 2. I lost my answers. They are -10, -1081. Find the value. If I cross multiply this, that's -1 minus 8 is -9. I think it's -1 times -1 plus 8 times 0. I think this is the first line. You do row 1 times column 1. Right? So it's row 1 times column 1. And that gives me -1. And this gives me 1. Find the value of the first row and second column. So that's going to be row 2, column 2, -1 times 0, and 1 times 1. This guy, which just gives me 0. And you just keep going, and you're going to prove it. You're going to do it all. And then the second one's going to be the second row and the first column. So that's negative 8 times negative 1 times 1 times 8, which is negative 8 plus 8 is 0. And the real question is 1, 0, 0, 1. Which one of these gives me 1? This one. When these value, the resulting is shown in the matrix should be 2 by 2. It's going to be 1 tab 0, 0 tab 1, proving that the two are there. All right. Given M, find the inverse, and then use that to show. It literally is the same exact thing. I just did it, and easy. Use the Desmos calculator to find your inverse, and then it's straightforward. All right, next question. Given that, find the inverse, and then show. Same exact thing. Given this, find the inverse. 11 parts. Oh, just because there's more rows, right? This one also has 11 parts. Yeah, there are more rows because you're going to do row 1 times column 1, row 2 times column 2, row 3 times column 3, and fill it all in for each exact different, all the spots. But you know the answer is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. I sound like a binary computer. Oh my goodness. All right, moving on. Find the inverse, and then the given matrix is if it exists. So what is that? That's 3, that's 24. Probably doesn't exist. 1 divided by 0. That's 15. That's going to be 20. This one will exist. It's going to have an answer. So use the tool. Find the inverse. Note that each inverse can be found mentally without the use of a calculator. So find the inverse. Isn't this one just... Really? It can be found without? To find the inverse, first form the augmented matrix. But it says it can be found without the use of pencil. Oh. I get it. I get it. I get it. I get it. So then, just for laughs, this one will be 1 divided by negative 9. Tab 0, tab 0, tab 1 divided by 10. 1 divided by 10. Huh. There you go. Find the inverse of the matrix if it exists. There you go. Use the calculator. Same exact thing. Oh, here they just want you to find a to the negative 1 and a squared. Pretty simple when you have a calculator. Encode the message math is fun using the matrix A. Remember to partition the numerical message in groups of 2. I know how to do this. I'm just trying to figure out what's the best way to do this. Let's do a matrix calculator. I'm going to put this here. Alright, so first, what's the coded message? Well, the coded message is... What number is M? I need to know what number on the alphabet M is. Let me see if it gives me in the view an example. Does it give me that in the view an example? There we go. So here my word is math is fun. So it should be I'm gonna do it like that, and then right underneath it I'm gonna go M is 13, A is 1. Should I put a 0? Did they put a 0 for the space? They put a 0 for the space. So M-A-T-H, M-A, what's T? T is 20, H is 8, then 0, then I is 9, S is 19, space is 0, F is 6, U is 21, and N is 14. So that should be my message. So let's try that. My coded message is 13, 1, 20, 8, 0, 9, 19, 0, 6, 21, 14. 6, 21, FU, this should be 6. MATH space IS space FUN. I'm off. One, two, three, four, five, six, 7, 8. No, what's this? I can't. What am I in groups of 2? Huh. Where'd I get confused? Oh, they want a 0 at the end? Who puts a 0 at the end? Seriously, who does that? This is a 14, 14. That makes no sense. Math is fun. Check answer. You have multiple. Did you? What does it want? Does it want a matrix in each of these? Which way did they go? 6, 9. Oh, they went like that. 6. Okay. So that means I got this. We got this. So here I need a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We need a 2 by 6. I need a 2 rows by 6 columns, and this one's going to be 13, and then it goes 20, and then 0. Oh, snap. Why does it go that way? 13, and then down here should be 1. Then up here should be a 20. Then down here should be an 8. Then up here should be a 0. Then up here should be a 9. This one is a 19. This one goes down to 0. This one goes up to 6, 21, and 14. And then what I want to do, if I know that A is going to be equal to 1, 1, 2, 1, 3, if I then multiply A times B, I get that. Okay, I found this. And then 15. I need my letters again. Oh my god. Enter. What's 15? 15 is O. 16 is P. 36 is 10 because it's 26 minus that, which puts me back to J. 44 is 26. What is that, 26 plus 18? So 18 would be R. 18 is R. 27 is A. 19 is S. 48 is 4 more than R. 1, 2, V. Oh my god, what's 69? 25, 62. 62 is 17. What's 17? That's Q. 14 and 14 is N. N. Is this my coded message? Let me see. O, P, J R R A S S V. Oh crap! I gotta hit tabs. O P J R R A S S V Q N N. What are you looking for? The numbers. Is O equal to 15? These are my numbers, right? 15, 16, 36, 44, 18, 27, 19, 19, 48, 69, 14, 14. That is a annoying, but I got it. Does that make sense? I think that makes sense. You put in the matrix A, you put in going top to bottom for B, you multiply A times B, you get the numbers, it wants the numbers. That was actually a lot easier. Code breaker, same thing. Just got to convert that, put a space there and a space at the end, and then you can do it. Oh, it's probably a space only if it's a number. 1, 2, 3, 4, 5, 6, 7. Oh, it's the same thing. Math is fun. 15, 16, 36, 44, 27, 18, 27, 19, 27, 15, 16, 36, 44, 18, 18, 27, 18, 27, 19, 19, 19, 19, 48, 69, 14, 14. Cool. Last question. Here we go. Encode the message arrive Budapest Orient Express using the 4x4 encoded matrix beat given below. What is going on? Oh, it is going to work. Arrive Buddha, Budapest, Orientexpress. 1, 2, 3, 4. You're turning. Special characters like J and T have bank around them to separate them from the rest of the zeros. So instead of cats, C A T C A. Oh, I get it. 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 Okay. So now this is going to be a 1, 2, 3, 4, 5. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. I'm going to do 32 because then it's going to be a 4 by 8. So my matrix is going to be a 4. I'm going to bring this over here. going to be a 4 by 8. So let's just clear all this. A new matrix. Oh, what's B? B is going to be B is a 4 by 4. Let's make this one B. No, I'm going to make it a 4 by 8. Rows. Oh, I gotta do 6? I can only do 6. Dang. Oh boy, I can only do 6, and then that gives me 24. Snap. I can't add any more. So what do they recommend I do? Yeah, I got that. This message is encoded. One, two, three, four, five, six, seven. Yeah, I gotta do a matrix where it's a 6 by 8. Yeah. And then what? Multiply that? Oh my god. I need a bigger, I need a higher order matrix multiplier. Oh boy. Where'd Desmos go? I lost Desmos? Um, Matrix calculator. Matrix A. What do I need? I need a 4 by 4, and then I'm gonna be multiplying. Matrix B is a how do I do this? Um, Increase, determine inverse rank, multiply row. Oh, I don't know how to. I'm gonna try to find this. Give me a second.